solar power holds significant promise in combating the planet's energy crisis. One audacious proposal goes well beyond conventional solar farms, suggesting we cover the vast expanse of the Sahara Desert with solar panels. This endeavor, while dauntingly ambitious, carries potential rewards beyond our current energy needs. The Sahara Desert, spanning over 9 million square kilometers across North Africa, is both the world's largest hot desert and an optimal location for a solar power infrastructure. It enjoys over 3,000 hours of sunshine annually, with a high solar irradiance potential of about 2,600 kilowatt-microwatt, making it a hothouse for solar energy production. The concept of covering the Sahara with solar panels isn't new, having been proposed by experts and enthusiasts alike over the last few decades. The hypothesis consistently resurfaces whenever renewable energy solutions take precedence. Harnessing the Sahara's solar power can have momentous implications for our global energy demands. Existing technology can convert Saharan sunlight into approximately 22 million gigawatt-hours each year, enough to power the entire world more than 1,000 times over. Moreover, estimates suggest that covering just 1.2% of the Sahara with solar panels could generate the equivalent of the entire world's electricity consumption in 2017. Meanwhile, the significance of such a project extends beyond pure energy generation. With worldwide energy consumption on the rise, there's an urgent imperative to transition to clean energy sources. Utilizing the Sahara for solar energy could drastically reduce carbon emissions, helping mitigate the effects of climate change. Simultaneously, it could fuel economic growth in Africa, creating jobs and stimulating technological innovation. Moreover, it could facilitate cheap, abundant energy for water desalination projects, potentially alleviating water scarcity in arid regions of Africa and the Middle East. However, the idea of covering the Sahara with solar panels is not without a multitude of challenges and potential negative consequences. First and foremost, the project's scale and cost are colossal. Current estimates suggest that the project would cost approximately $5 trillion. Even with falling solar panel prices, the cost of installation, maintenance, and the necessary power grid and storage infrastructure could prove prohibitively high. Additionally, manufacturing and installing millions of solar panels would cause a considerable initial carbon output, potentially offsetting some of the project's environmental benefits. Also, the manufacture of solar panels involves the mining of rare metals, putting an extraordinary strain on these resources. Another significant concern is the potential impact on the Sahara's fragile ecosystem. Solar panels can create a microclimate, absorbing and re-emitting solar energy, potentially leading to higher temperatures and altering local weather patterns. This phenomenon, known as the heat island effect, could negatively affect the Sahara's biodiversity, including migratory bird pathways and the survival of desert species. Finally, there are socio-political implications to consider. The Sahara spans several countries with complex political realities, making a multinational agreement challenging. Moreover, the question of energy distribution control and profit share could potentially deepen existing regional inequalities. In conclusion, the idea of harvesting the Sahara's solar potential by covering it with solar panels is as fascinating as it is complex. While it offers a potent solution to our energy needs, it brings with it an array of operational, ecological, and socio-political challenges. However, considering the urgency of our transition to sustainable energy, these are hurdles we must confront. As we move forward, it will be necessary to balance the vast potential benefits of this project with its significant environmental and social costs. The concept reaffirms once again the complexity of the path towards a sustainable future.